Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. So here in this question, it is given that you drop a ball from rest in the downward direction. So its initial velocity would be 0 because you drop it from rest. Now at the same instant, your friend throws ball B, this is ball B, in the upward direction from the ground. This is ground here. And this is the roof. Now it throws in the upward direction with the initial velocity V0 such that it can reach up to here, up to the roof. Now we have to tell the direction of velocity and the acceleration of each ball at a point halfway between the ground and the roof. So halfway would be something here. So when this ball reaches here, something like that, and when this ball reaches here, something like that. Now we have to tell the direction of velocity and acceleration for both of these two balls. So this is ball A and this is ball B. Now this ball would be moving in the upward direction like this. Now one more thing, we have to assume upward direction to be positive. So this is given in the question. So this direction we have to take it to be positive. So this direction would be negative. Now let us first find the direction of acceleration. Now since both of these two balls are in free fall, so acceleration would be in the downward direction always. So for ball B, the acceleration would be in the downward direction, and for ball A also, the acceleration would be in the downward direction. Now since we have taken the upward direction to be positive, therefore acceleration for ball A and ball B would be negative because it is in the downward direction. So we can write that the acceleration for ball B is negative and the acceleration for ball A is also negative. Now let's see the velocity. Now the ball is this white ball is moving in the upward direction. So the velocity for the ball, this is ball B, sorry, will be positive because velocity is in upward direction but acceleration is in downward direction. So velocity would be positive. So velocity for ball B is positive. Now this ball A is moving in the downward direction like this. So in the downward direction this is negative. So the velocity for ball A, this will be negative. So we are given with this position versus time graph for a particle, and there are two parts in this question that we need to solve. In the A part, we need to tell is the average speed for the time interval between the points 1 and 2 greater than, less than, or equal to the average speed for the time interval between points 1 and 3. Now we know that the average speed of the object is the magnitude of the slope of a line between the 2 points. So the average speed between point 1 and 2 will be the magnitude of this slope, the slope of this line. And similarly, if we join the point 1 and 3, the slope of this line will tell you the magnitude of the average speed between point 1 and 3. Now here it is clearly visible that this slope, let this line be A and let this line be B. Now slope of line A is greater than the slope of line B. Therefore the average speed between the time interval 1 and 2, so let me write here, the average speed between the time interval 1 and 2 will be greater than the average speed between the time interval 1 and 3. So this would be the answer for the A part. Now next we're going to solve the B part, where we have to tell the average velocity for the time interval between points 2 and 4 is greater than, less than, or equals to the average velocity for the time interval between points 3 and 4. Now the average velocity of the object is the slope of a line between the 2 points. So let me join these 2 points. This is, we have to take 1 and 2 and 4. So this is 2 and 4, and then we have 3 and 4. So 3 and 4 would be like this. Now let this be this line C, and let this be the line D. Now here it is clearly visible that the slope of line, this is line D, slope of line D is greater than the slope of line C. Therefore we can conclude that the velocity between the time interval 3 to 4 will be greater than the velocity for the time between the time interval 2 to 4. So this would be the answer for the B part. So here in this question we are given with this velocity versus time graph for an object moving in a straight line. Now there are 3 parts in this question that we need to solve. In the A part, we need to calculate the acceleration of this object, and we know that the slope of a line on VT graph tells us the acceleration. So if we calculate the slope of this VT graph, it would be the acceleration. So if you put if you find the coordinates here, this coordinate would be, now here this is the time is in, this is 0 here, and the distance is 0.5, sorry, the velocity is 0.5 meter per second. Now here the coordinate will be, this is time is 1 second, and the velocity is, this is 4.5, so 4.5 meter per second. Now the acceleration, so we can find the slope. So this would be, in this case it will be delta V over delta T. So delta V, we have 4.5 minus 0.5 divided by delta T is 1 minus 0. So that would be equals to 4 meter per second squared. So this is the acceleration of the object, and the answer for the A part. Now next in the B part, it is given that if the object at x equals to 12 meter at time t equals to 0, what they are saying is that at time t equals to 0, the initial position for the object is 12 meter. Then what is the final position at time t equals to 1? So here what would be the final position? This is what we have to calculate. Now there are multiple ways to find this answer. You can use this equation. This is xf is equals to x naught plus v naught t plus half at square. You can use this equation. xf we need to find, initial position we know it's 12 meter, initial velocity we also know, here the velocity is 0.5 meter per second, time we know, we need to calculate the xf at time t equals to 1, so we can put t as 1 here, and acceleration we have calculated. So we can use this equation. Another way we can do one thing, we can find this total area under this curve, and we know that the total area under this curve would be the displacement. So we can calculate xf by this way also. xf equal to x naught plus delta x. X naught we have 12 meter, and delta x would be this total area would represent delta x. So we can do one thing, we'll go to use this method. So the total area under this curve would be, we can divide it into 2 portions like this. The upper portion is a triangle and the lower portion is a rectangle. So delta x will be equals to, now lower portion, the area of the lower portion, this portion would be, length we have 1 and width we have 0.5. So 1 multiplied with 0.5, 1 is in seconds and this is in 0.5 meter per second, plus the area of the upper portion, this is a triangle, so 1 over 2 half base into height. Base we have 1 minus 0, that is 1 second, and height we have, this is 4.5 here, and here this is 0.5. So 4.5 minus 0.5 is 4. So this would be 4 meter per second. So from here delta x comes out to be as 2.5 meter. So the final position of the object at t equals to 1 second will be x naught, we have 12 meter. We are putting everything here, plus delta x we have just calculated 2.5 meter. So that would be equals to 14.5 meter. So this would be the position of the object at time t equals to 1. Now next we are going to solve the C part, where we have to assume that the acceleration remains constant for the object. Then what is the position at time t equals to 1? Sorry, at time t equals to 5 seconds. At this time, what would be the position? So now we can use this equation directly, this one. So we are solving the C part. Let me write the equation. xf is equals to x naught plus v naught t plus half at square. Now we need to find the position at time t equals to 5 seconds. So we can put all the values here. X naught we already know, it is 12 meter, the initial position of the object. V naught is the initial velocity, which is 0.5. So 0.5 it is in meter per second, and time we have to take it to be 5 seconds, plus 1/2. Acceleration we already calculated, 4 meter per second squared. So 4 meter per second squared multiplied with time square, so 5 second, and it's squared. Now it's pretty simple. We can use our calculator to solve this, and we'll get the final position to be 64.5 meter. So this would be the final position of the object at time t equals to 5 seconds.